Hi everyone, in this video, I'm going to go over the brief theory of the lab for the acid content in fruit juice. And I'm going to also talk about the pre-lab questions, and then we're going to end with the procedure in part A. Okay, so the goals for this lab is for you to figure out the concentration of hydronium ion available in the fruit juice, and also the amount of the total acid in fruit juice as well. And we're going to also take a look at the percent ionization of the acid. Recall from Chem 122, you did the separation of the acid in juice before, right? So we use the paper chromatography to looking at what are the content in your acid fruit juice, right? So these are the acid that is available in the fruit juice. Okay, so we are going to be based on our knowledge here to help us figure out what would be the total amount of the acid in fruit juice then, right? So each juice, they are going to have a different type of organic acid. These are the weak acid. Okay, so these are not strong. Okay, so these are weak acid. So they are going to be present in the fruit juice. What would be the amount of them is going to be different, right, for each type of fruit juice. Okay. So what we're going to do today is that we are going to use titration to help us determine the amount of total the acid. Okay, so what we're going to assume is that the available acid that we have, they are going to be the monoprotic acid. Okay, so we're going to use this amount of the unknown acid to react with sodium hydroxide. So same idea as last time as well, right? So then we're going to stop titration when they reach the endpoint. Okay, so in this case, the known volume of sodium hydroxide and also the molarity of the sodium hydroxide will allow us to find out the mole of sodium hydroxide, and then later on, we will eventually know the mole of acid that react, right? So that means it doesn't matter how many mole or what type of acid that we use. We don't care about what type. What we are going to look at is we're going to look at in terms of the total overall acid. Okay, so the amount of acid available in fruit juice, we are going to assume that they are going to react with sodium hydroxide that we titrate. Okay, so how do we calculate all of this then? Okay, so the first thing we're going to take a look at is going to be the total acid. Okay, so the concentration of the total acid in fruit juice can be calculated from the mole of sodium hydroxide, which is going to come from the volume of sodium hydroxide multiplied by the concentration. Okay, and then we're going to divide this by the volume of the acid or the juice that you use, right, to titrate with the sodium hydroxide. So in this case, we are going to measure out 25 milliliter of the acid from using the pipette. Okay. So the volume of sodium hydroxide would come from the reading of the burette, right? So you are going to read the initial and you are going to read the final after it reaches the endpoint. And the concentration of sodium hydroxide would be written on the bottle. Okay, so that means you have to jot down the concentration of sodium hydroxide as what you did from last time. Okay. And what about the percent ionization then? Well, percent ionization will equal to the amount of proton available, right, divided by the total acid, which means that how much proton actually dissociate from that acid, right? So that's what the percent ionization mean here. So that means from the first calculation, you are going to end up using that total acid there. What about this amount of proton then? Well, this is going to be the amount that come from the pH. Okay, so it's going to be the pH, the initial pH reading of your fruit juice. So that means you need to measure the pH of your fruit juice first, right? So whatever that value is, you are going to do the anti-log, right? So that would be 10 to negative that pH. That is going to give you the concentration of proton. Okay, so then you can plug it in here. Eventually, you're going to get the percent ionization. Okay, so that means if you look at pre-lab question 2, so this is going to be an example of how you calculate your post-lab as well. Okay, so for example, let's say that the fruit juice that you measure out, the initial pH of that juice is 3.58, right? Let's say that you take out the fruit juice 25 milliliter and you titrate with sodium hydroxide at this concentration. Again, for the lab, right, the actual lab, the concentration might be different, right? So you need to look at the concentration from the bottle. Okay, and then let's say like you titrate this sodium hydroxide, this is the initial reading and that's the final reading, right? So the first thing is, how can we calculate the concentration of proton? Well, the answer is what we did in class before, right? So it's going to come from 10 to negative pH. So if I do that, I'm going to get 2.6 times 10 to negative 4 molar. So this is the concentration of proton. Okay, so it's come directly from the reading of the pH of the fruit juice, okay, before you do titration. Then in order to find out the total acid, then all you need to do is that you are going to need to find out the total volume of sodium hydroxide used first. So therefore, you're gonna do final minus initial of the volume of sodium hydroxide, right? And then multiply by the concentration of sodium hydroxide. So for this problem, it's giving us 0.15. But again, for the lab, it will be something else. And then you are going to divide this by the volume of the acid, right? So I'm going to divide by 25 milliliter. You might ask me, hey, Ami, wait a second. Well, I thought that this, in order to get more of sodium hydroxide, the volume have to be a liter, right? Because this is mole per liter. So how come that you leave it as milliliter? Well, the answer is the reason why I leave them both as milliliter, because the milliliter and milliliter will cancel each other out anyways. So the final unit would be this uppercase M, which is mole per liter anyways. You are welcome to change this to liter first and change that to liter first as well. But as long as these two units are the same, okay, so the top and the bottom unit are the same, you actually don't have to to convert them, right? Because they will eventually cancel each other out. Okay, so just so you know there. So again, you are welcome to change to liter, but again, the reason why I don't have to change here because the milliliter and milliliter can cancel each other out. Okay, so if I do that, right, so this ml cancel out, so the final unit would be in mole per liter. Okay, so the last one, in order for us to calculate the percent ionization, then this is going to be the amount of proton divided by the concentration of the total acid, right? So that is going to come out to be 0.11%. Okay, so that means the weak acid, right, in this fruit juice is very weak, right? It's only ionized, only 0.11%. That's what it tells me. The next pre-lab question asks us, why cannot we use indicator to visualize the endpoint of the fruit juice titration? Okay, so if you think about this, fruit juice contain color, right? So if you add indicator that also contain color as well, pretty much the fruit juice that contain color will obscure the color change of the indicator, right? So therefore, you will not see how the color change very well, right, to determine the endpoint. So what we're gonna do instead is that we are going to pretty much determine the pH value at the endpoint instead. We are going to use the pH meter to help us obtain the pH value, so that way we know exactly when to stop titration. And in order to do this, we are going to use acetic acid, because acetic acid is colorless. We're gonna titrate acetic acid with sodium hydroxide. Note that this acetic acid here is the same component that you did for the titration from last week, right? It's the component that found in vinegar. Right? So the reason why we are able to do this to get the pH at the endpoint of acetic acid and assume that it's going to be the same pH as the acid in fruit juice, because fruit juice, right, contain acid, and those acid are weak acid as well. Okay, so therefore we're gonna assume that when you have weak acid, right, titrate with sodium hydroxide, we are going to assume that the salt that come out is going to be basic salt that is going to yield similar pH value. Okay, so we are assuming that. So that means in this case, part A, right, you are going to, this is exactly what you're going to do. You are going to add acetic acid together with sodium hydroxide, right? And then make sure that you add indicator as well to see the color change. And the color change at the endpoint would be the faint pink color. And after you get that, then all you need to do is just measure out the pH at that point, right? So once you know the pH at that point, then that's going to be used for your titration for part B. Note that in part A, you will have to do this by yourself. Okay, so again, the goal of this is not to find out how much sodium hydroxide you use, but the goal of this is to find out the pH at the endpoint, which means that when you have acetic acid, all you have to do is add indicator in here, right, phenolphthalein in the indicator, and you are going to add sodium hydroxide into it. Okay, so once the sodium hydroxide turn the color into faint pink, you are going to stop the titration, or you are going to stop adding sodium hydroxide. Okay, so you do not need to jot down the volume of sodium hydroxide used. Okay, so all we want is the color. Okay, so once you get this color, all you need to do is going to be measure out the pH, right? So you need to rinse your pH probe, right? And then like stick it in to read the pH at this point. Okay, so that would be the pH at the end point that you will need to use for your part B. Okay, so because each of you will need to do this on your own, so therefore each one of you going to have your own pH at that endpoint. Okay, so then you are going to average that pH between you and your lab partner. Okay, so the average pH here at the endpoint is going to be the pH that you are going to use in part B. Okay, so part B, you're going to use this average pH. Okay, so to stop your titration. Okay. What happened then, Army, like if I add too much, right, so of sodium hydroxide, and then the color is not become faint pink anymore, it's actually fuchsia color. Well, if that's happened, don't freak out. You don't need to redo it again. All you need to do is add more acetic acid to this, right? So as you add more acetic acid, you're gonna have excess acetic acid. So it's going to change the color of this into colorless or like even like lighter pink, right? So all you need to do is just add acetic acid and sodium hydroxide in such a way that eventually you will need to get this faint pink color.